الماضي 5 درجات، المرة هذه درجتين. It's up to you. So we continue. So we continue. We said that this buffer overflow is one of the main actors to harden an operating system. Why? Because none of the running software, threads, processes, whatever they are, that they are running on top of the processor, it can be found out of the volatile memory. More precisely, we talk about the buffer. Thus, it has to be secured at a level of 100%. We cannot guarantee the 100%, but we can raise the security of the buffer. Mainly, we talk about the buffer overflow as an attack scenario for the buffer itself. We reached to discuss 3 or 4 topics. Let me check. Yeah, exactly. We reached the sandbox and scenario. And yes, and we defined the ActiveX also, the countermeasures versus the attack of the ActiveX. Still on the browser is actually a scenario via which we are going to harden the inputs and also the outputs points versus the operating system, the browser itself. The context we are seeing right now is the cross-site script, and we saw that actually in the lab when we discussed the facing scenario and the chatbot, lab number 4. Here we are going to define it theoretically, the cross-site scripting. We're going to make through the technology here, okay, the cross-site scripting through this technology. It's not we are going to do it, but we are going to make an injection of a script to make actually change the behavior of the expected website or whatever, or the website in question. The chatbot box we discussed actually in the lab. We injected JavaScript and we injected CSS style and tags, via which we reached to hide and we reached to change the destination of the page itself. So what we did at that time, it is a cross-site script sample. We injected a JavaScript script to change the behavior of the interface we are seeing. And it was not local, it was on the server side. What I did myself, you were able to do it, and what you did it, some of you actually, some, not all of you, I checked, I have my database. I was able to see that from my side, from my end. So that was successful. That was example of cross-site scripting. It is a malicious attack that has to happen on a web browser, tackling a web application mainly. And not only it is a web application, but besides it has to be a dynamic web application. Means it has a background data source via which it is delivering responses to users. And that is the aim of this attack, the cross-site scripting, which is the background data source. We're going to hide, we're going to delete, we're going to alter, to add, and to data, whatever the payload of this attack, but we are attacking the background data source. We are going to, as we did in the lab, involve and infer the client-side scripts like the JavaScript and CSS. Very easy. Samples only. ActiveX here are talking, if we are talking about the Edge and the Internet Explorer, Microsoft-based browsers. JavaScript is standardized for all. I'm going slowly just to make you actually be attracted if you are able to understand what I'm saying, because this is clearly related to your lab. Okay. Scenarios we did in the lab, exactly it is fitting this point, because we were able to hide all the content of the chatbot at that time. We displayed another message, your interface has been hacked or something like that. It was a message, we displayed something instead of the available content of the chatbot. The engine itself is hidden. We reached to hide using that XSS attack at that time. Great. It has to tackle web applications mainly, and there have to be input points for sure. There have to be input points in order to succeed. We cannot do an XSS attack if there are no input points. If there is only, for example, images and texts without links and without input points, text boxes, or let's say the text fields, or let's drop-down menus, we cannot do anything. We cannot do anything. There have to be actually such components, controls, in order to be able to achieve such attack, to succeed. Even we can fail, but to do it, to apply it only, to apply this cross-site scripting, there have to be input points, otherwise we will fail. And I was saying that this would actually be able to happen, but might fail. What does it mean? It means we will be able to try the XSS attack, but we will fail. Why? Because there is a countermeasure happening there. Means there is an input validation. In a chatbot, we are not expected to write JavaScript or let's say CSS or something like that, commands from ActiveX. We are not. No. In the WhatsApp, are you eligible to write JavaScript content? You are sending text messages, images, video, something like that. So the chatbot is to communicate media between non-technical parties. But even if you write code, HTML or JavaScript or CSS, it has to be sent as a textual content, not a scripting content. How to happen? Because of the input validation. Because of the input validation. Input validation. There have to be an input validation in order to succeed, to fail any sort of cross-site scripting attacks. Input validation is the scenario, is the solution. So the scenario via which we need to see in an XSS attack to say that the XSS might happen, the doer, which is actually a skilled party, whatever, the skilled party might be even a chatbot. You remember the botnet, the zombies, chapter number 1? Yes, they can be attackers in doing a cross-site script attack. True. It means malicious content, they can be attackers. A destination web server where a web application resides, where a web application resides, whatever, like the eBay, like the Amazon, like the OLX in Oman, like the Souq Oman, whatever, any web application or a web server, and there have to be a terminal with the attacker, a terminal, because we might use a browser, or we might use actually a direct command line interface, if it's the case. So there have to be a terminal. Mainly we talk about client, where the service has been sent to the client here. Mainly we talk about web browser. Okay, here is actually a graph here which we see the attack scenario. A request has been sent to a server. The server will be actually receive responses and whatever replies from a client, and there have to be actually a message to be communicated. Whatever the message is controlled by the attacker. Here I have to show you, because I did it with a sequence. I'll make you see the malicious script here will be sent to the server. Then the server stores this malicious script. Whatever. Here is actually the example. Script. Since it's a script, it means it's a JavaScript. Then the user requests the message. Actually, the reply. Whatever. Reply to his response. He's sending a response, something like that. Give me a form for something. The server will send the infected content, like we did. We completely changed the content of the chatbot to a message we displayed. The message, instead of that message, there can be something different, because we did it safely. We did it in a very good way, in a very good ethical way. We just displayed the message. We hidden the interface, and we display the message. But instead of displaying a message, there might be a form. which is more dangerous. Yes, can be 100%. Then after actually, it has to be the message would be sent. This infected message would be sent to the client, and then the browser, the client here actually displays, executes, renders the message content, which would be actually displayed to the client at the end of the day. Here actually, this client, if he uses this content, that's all. The XSS has been succeeded. The XSS has been succeeded. Yeah, I remember that we are dealing only with HTML content since we are talking about web solutions. The attack is to be happening on the web server, the service provider. Certain types of activities to be happening. We hide the content, maybe. We communicate data, or deface by sending a form or links or something like that, the content of the page. Or we may even compromise the device to do remote controls or remote activities on that compromised device. So we can do all. We can do all kinds of. We can execute different payloads. Good. Another scenario via which we see the XSS in action is via the use of the global variables. Here we are not going to use a text box or a link from inside the page. No, we are going to use a global variable. See here, we are having a domain, and at the end of the domain we have a global variable. This annotation here is a global variable. You have to know what is the global variable from the internet technology. Question mark and a variable name, then equal something. At that equal, we may pass our content, whatever we want to pass. If there is no input control or input validation, this attack would succeed. See here. This attack would succeed. It is because the web application will read and will execute, will compile this content. And here is the result. See this one here, the result. So the XSS has succeeded. We did it and we succeeded using the global variables. Well, okay, as a countermeasure for the context of XSS, cross-site scripting, is the input validation usually. The input validation, whatever the users have to input, whatever the users in plural have as input points, those points, they have to be validated. Means they cannot type whatever they want. Or at least they cannot submit whatever they want. Everything has to be controlled and has to be submitted according to the application owner, according to the developer or the webmaster. Means there have to be a control on what the users submit. Any questions here, please? Any questions, please? Any appraised requests or comments? If you are saying no, actually, that means you are understanding completely what this topic is about. And here, I may ask you, myself, the question: what are the input validation procedures? Actually, what does it mean, input validation here? Those are some of the constraints that we can go after in order to validate the inputs in a web application, no more, no less. And they use reference for view and the input validation content, input validation example, whatever. Regardless. So here, actually, this is an example of the interface. Actually, since we are using username of password authentication, means there is a background database or data source where the usernames and passwords, they are being checked. Here we may apply an XSS. We saw the SQL injection, the SQL injection first class at the beginning of this semester, but even we can do a different attack now. This is the second attack that's been applied here, is the XSS. Why? Because this is a dynamic input, this is a dynamic interface. And the XSS is to be applied in a dynamic web application, web solution. So successfully this interface fits to try an XSS attack. Means now if I ask you, anybody in an interview or wherever you are in a different, whatever the scenario is, you are asked, this is an interface, what are the issues that can face this interface, and what are the countermeasures? I repeat the question. I may give a minus now if I ask you and you don't repeat what is the question, not the answer, the question itself. If you don't repeat the question, please be aware I might give you in mind. So follow, concentrate. I need your attention. I said if you are in an interview or any scenario, actually a professional, let's say a framework, you've been asked this web solution, this web interface here, what are the digital security issues or vulnerabilities or problems that may face, and what are the solutions, the countermeasures for such interface, for such problematic view? This is the question. The answer is we saw, actually it's not because we are not going to limit, but we saw two security issues, which are the SQL injection and the XSS. SQL is based on the use of the SQL queries. You are going to modify and to inject a SQL query modified in order to try to extract or to modify or to detail the behavior of this interface, to access a system or to retrieve credentials. Yes, we can. Since 100% it is interrogating a data source in background, username and password. The second attack is the XSS. What is it? It is to inject a script to also either deface or change the behavior of this interface. Either to deface, change the direction of this interface. Instead of logging into the system, it will log to a different system. This is deface and act. Or also we can hack and open access this system, whatever. We can do that, absolutely. So input validation, it would read actually all the contents here, whatever the user types here, and it has to check up if he's allowed to type such content or not. Usually that means the input validation. The same scenario he explained in this attack, this exact attack only. But here actually is for a defacing task. Here actually we are going to do a deface attack in this scenario. It's only for the defacing attack. It is not correlated. It is not actually deprived the SQL injection from the XSS. Why? Because as per the example we discussed here, we are going to tackle the same interface using this for the same purpose. These defenses are the data execution, prevention, depth, and address space layout randomization. Iman, what do you want to say? I cannot get you. Depth and DSLR, they are two security measures from Microsoft for different purposes, not for this context, not for the XSS. They are from Microsoft mainly, and they can be actually found in different platforms, yes, but they are not for the XSS. They are defenses, true. They are true. They are defenses, but not for the XSS.
Answer before question, Mr.
Which question? Can you remind me? اذا عندك سؤال you can actually I don't know but اذا هو مربوط بالشيء هذا فهي من مايكروسوفت وليست مربوطه بالاكس اس اس، لا علاقه لها بالاكس اس اس، الداب وليس الار، هي اجراءات حمايه. نعم I believe absolutely. What is the role of the buffer flow? No, here actually the question said the role, not how to defend it. How to defend the buffer overflow, how to defend the buffer overflow. إجابة تكون داب ولا SLR، ولكن لماذا نقوم بالحماية من البفر overflow؟ الإجابة لا تكون DAP ولا SLR. We cannot answer with the DAP, data execution prevention and the SLR. الحماية من البفر overflow because it's one of the pillars. موجودة في أول الفيديو مسجل actually at the beginning of this recording. We are going to harden the operating system. Why we refer to the buffer overflow protection? Because every and none of the running processes, threads or applications, they can be found outside of the volatile memory. More precisely, we talk about the buffer. And if any problem or problematic view happens there, so the full application or it can cause the full system to stuck and then after service interruption. So to secure a buffer is one of the very vital approaches. It has to reach the level of 100% security. We cannot reach the 100%, but we have to raise it as max as we can as security experts. Let's continue. I was saying that the SQL injection is not deprived from the XSS. Why? Because both of them, they attack the same, let's say, attack interfaces. They are dynamic, they are web-based, and they can retrieve data from a back-end source, or they can hide, not retrieve data from being displayed. So they have common points altogether. Okay, web form, these whatever. The context of the validation. So yeah, exactly. The validation is for the purpose of denying the payloads from being executed. Why? Because the SQL injection is the context of a direct payload to be injected. The XSS is also a sort of a direct payload to be injected. When I say I'm going to do a deface, what is that? Am I going to download? No, I'm directly executing my malware, which is the deface, which is having as a purpose the deface. The same thing when I try to retrieve data, retrieve credentials using the SQL injection or SQL injection. Am I going to download something or wait for something to happen? No, directly I'm doing the attack. So those validations, they are actually tackling different purposes. Variations, yes, we can see them here as variations, but they are going to execute a payload, whatever. The payload. Remember the malware intention here. It's a malware. The SQL injection is a malware. The XSS is a malware. It's a malicious behavior. It's not malware. It's a malicious behavior. Differences. Yeah. Input validation has to happen. Input validation, we said that it has to be controlled. Every input point has to be controlled in the sense of making the user only input what the developer wants or what the application needs for a good behavior. To do so also for this measurement, we can go for prepared statements. Here is a Microsoft approach, and the sort of procedures also. It's a Microsoft approach. Here we are going to prepare one request to be utilized again and again and again in order to make the user click a button instead of writing something. Prepare the statements means the user, he will not type anything. He will just click choose from the list. This way, we forbidden the input, but we give the serves. Still, we do not block the serves, but in a different way. The stored procedure, the same scenario, but here is one statement. Here we may have more statements. Procedure holds a scope, a beginning and an end, means a list of statements to do. And also we can control users. They cannot have all the functionalities available. Example, the EduWave and the students. You do not have all the functions to see inside the EduWave. But me as an instructor, I have a little bit more than you. CIS people here, the administrators, technical administrators, they have more and more privileges than me and than you. So here we are controlling the privileges, what you can see based on your role inside the system. Okay, other components that we have to check up and to control is the context of the communication channels. In the sense of, we are going to talk about the emails or message and applications. So they have to be actually controlled, because how to open an email, as per an example, we have to use a browser, a client, to help us open an email, to display the inbox content, or to send emails, to share resources. So this is another channel that has to be secured, because it is an input, it is causing an in-out flow to and from the operating system. Open relays, they are sorts of servers. They are available over the public networks that they help users to communicate through the use of the emails mainly. The open relays, they are sorts of interrelating devices that come between the source and the destination. I give you the example. I'm going to send an email, for example, from here, from our campus, from University of Nizwa, to Massachusetts in the United States of America. Okay, is there any direct link from my device here to the Massachusetts actually device in the server there in the United States, whatever? No, absolutely no. Neither the mobile, the wireless communication, neither the landline actually communication lines. Never, because there is no direct line. There is an intermediate devices. Amongst of them, they are the open relays, open relay device one, and in plural we are talking about open relays. Those are for the context of the email sending, simple mail transfer protocol. For the context of the email sending, they are having the role of to receive what the client has sent as an email and to direct it to destination. Okay, Murad has sent an email to Massachusetts. Here, let's send it here. Murad sent an email to unknown body. They will block it because they do not know where to send. So they only make an relay in between the sender and the receiver. Open relays. Okay, this is the technology. This is the technology. What's the problem? The problem is that actually if they are infected or they are compromised, so they cause a problem here because they are going to send, because they are the ones that they actually receive and furnish the communicated media. So they have to be actually a question of security also. Whatever. Here we are not going to discuss the security related to those devices. Suppose that they are actually deprived from any malicious kind of malicious attacks. We are going to discuss the technology used for sending and receiving the medias, the emails or whatever, the protocols here used for sending and the protocols used for receiving the emails. They cause problematic abuse. Come back here. Okay, this is a kind of header, sent through actually an open relay. It is actually an email header, whatever. This is a technical representation. I'm not going to discuss the content because it is too technical, and just you have to know that this is not anything. This is a dedicated, clear, and very clear header sent with an email. Good. The two protocols responsible for sending and receiving communicated media, they are the simple mail transfer protocol, which is the one responsible for sending out. You send an email, this is the one that takes care of your sending mails outgoing. Okay, you're going to receive an email or you're going to check your inbox. Is it the same? No, it's the POP protocol, post office protocol. There are versions. We are talking about the POP 3, the version number 3 now available now on the market, utilized by the totality of the servers, the major servers actually available on public networks. Yes, this one to help you to send, and this one helps you to display the inbox. Those are the technologies. Here we are talking about an ameliorated, actually, version of the this SMTP protocol, in the sense of going to use a different version. Yeah, we can use that actually because of the complexity available in this one from outside. What does it mean from outside? Means if you want to hack this media, this protocol, to deface it, or to, let's say, to do any hijacking, it would be much more complex whenever we compare it with this SMTP. See, we're talking about sending emails only. Sorry. So, sorry. So here we are seeing a graph here which we are sending an email. Let me present here. I'm just checking. I want to show you something here, just for your understanding. Whatever, we'll come to it just in a while. Here we are seeing actually a scenario: a sender here, a sender, and here is a receiver. We have the media in between. Let's say the mediators in between. They're actually responsible for sending. Since we are talking about the SMTP here, since we are talking about the SMTP, no need to see the sender word. See, email sender. Here we are talking about SMTP. No need to write the sender. Why? Because we are tackling the SMTP. The SMTP can only send, cannot receive, cannot display the inbox content. The inbox content here to be displayed. Why? Because we are talking about the POP protocol. The POP protocol. Very good. SMTP, SMTP, SMTP. Why? Because still we are sending. Here, since we are going to receive directly, so the POP3 will come into action. POP3 will come into action. Exactly what I was saying now. So the SMTP is only used for sending, and the POP3 is for the receiving. Here, the SMTP, since it is sending out, the content, it is not the question of security of the security, let's say, experts. Why? Because we are going to send something out. It does not have any harm to you. But since it is going to go here without control, it might be injected. It might be actually falsified. It might be actually utilized to inject any malicious or any any payload to be carried out with the packets. So this is the problematic view of the SMTP, the loss of control. Yeah, actually, it can lead to expose the media. It can lead to expose the identification of the sender, receiver, and so on, without any consent, which is a hack at the end of the day. Yeah, not only the emails, they are a question of security in the communicated medias, but also we can talk about the instant messaging protocols, like the WhatsApp, live chat in Twitter and Facebook, and all the live messaging applications. They are a question of also security issues in the current days. Actually, we do not talk about the WhatsApp or the Facebook. They are actually exposed, but we are talking about the technology itself, the instant messaging protocol. Here we are talking about the technology enhancing the live chatting, the live communication, which is a question of security. Why? Because we cannot talk about a security in a live communication. Now, if I'm talking to you now, and you are listening to me now, do you think that an antivirus or a firewall or any filter, kind of a filter, security filter, will be able to 100% secure what I'm sending to you? 100% no and never. Why? Because it has to be in a lifetime. And if it happens to be 100% with a heavy media in size. It will need time, which will break the rule that it is instant. So it will not be happening in real time. So thus, this instant messaging solutions, they are a question of security. They have to be secured and they have to be tackled again and again and again and again. Okay, I'm going to stop at this level. If you hear your name, please say yes. If you hear your name, say yes.